Hello and welcome to Ask a Boardwalk Engineer, our series for trail and boardwalk designers, where we discuss the engineering and project questions that come up most often. I'm your host, John Pyle, and with me is our Director of Engineering, Andrew Craig. And today we're going to talk about some common misconceptions regarding precast concrete boardwalks. So I'd like to start with the one that comes up most often, and that is that precast concrete is a more expensive option than wood or composite.
Thanks, John. Yeah, cost is always part of the equation when you're starting a boardwalk project. It's not uncommon, as you would expect, that timber, especially on these smaller projects, might be a cheaper option when you're looking at day one, right? I mean, concrete is going to generally be a more expensive material than buying lumber for the boardwalk. But what we like to look at is really consider these life cycle costs. We had a client that shared some data on the analysis they did for boardwalk, and the concrete option was about 30% more, and that's on day one. But only 20 years in, the life cycle cost of the timber became twice that of the concrete boardwalk. So really the longevity of the concrete product having a lifespan of 50 to 75 years, whereas wood is more, around 15 years for its life cycle. I mean, that's something that should really be factored in when you're looking at the total cost. Another thing that I found interesting as we've looked at more and more projects is on larger structures. So think about boardwalks that are wider, might have bigger load demands for bigger vehicles, spanning further. On the larger projects, the concrete generally starts to become more cost competitive with the timber option. The concrete option is a pretty simple system, whether it's a smaller 7-foot wide boardwalk or all the way up to a 15 to 16-foot wide boardwalk. It's framed generally the same. You've got the concrete treads on top, acting as the planks, and generally two concrete beams. And so having just the simple system and only the two beams, even at the larger widths, really simplifies compared to the timber option, where as you get wider, you'll generally have to increase the number of joists, at a 12, maybe 16-inch centers is what we commonly see. Also, concrete, it spans further. Our standard system, we're seeing spans around 20 feet a lot of times, whereas most timber designs we see are more in the 10-foot range. And so foundations are a big cost on these boardwalks, a big component of the total cost. So cutting the number of foundations in half really helps that. And then on some of these larger projects that have really long boardwalks, that speed of construction is very important too. It becomes more and more important as the project becomes larger. The contractors can get in, and since it's a precast product assembled on site, they're able to move quickly and reduce those labor demands and kind of get in and get out. So cost is important. I think looking at the life cycle costs is critical, and then especially on these larger structures, you'll start to see more and more advantages of the concrete system.
Great. You mentioned life cycle cost. I think part of that is going to be maintenance associated with the boardwalk. So, the other misconception that we hear sometimes is that precast concrete has a higher maintenance cost associated with it. So can you speak a little bit to the maintenance cost of a precast concrete boardwalk?
Yeah, I can. I mean, the great thing about concrete, it does not rot, it does not splinter, right? I think we're all familiar with wood boardwalks or wood structures that have generally been worn down. Concrete really doesn't have a set maintenance schedule. I think a periodic power washing and a cleaning is probably good practice just to keep the debris off. The concrete itself won't really generally become slippery. I do get asked, is it possible for a boardwalk to become slippery over time, especially in a wooded, shaded environment? And like any material, if you get a lot of debris on the boardwalk that decomposes, you could see almost like a biofilm or a slippery layer. But periodic power washing is really the only recommendation we have. The concrete itself, we don't have a set maintenance schedule to replace pieces every so often or replace components. We've really tried to design the system where it's kind of one and done, and it satisfies that desire to have something low maintenance. I think my wife and I purchased a home a year ago, and I can kind of see the difference. It's a 35-year-old home, and we're already on the second deck, and we're considering either repair or replacement to the deck now. And then I kind of look at the driveway. The driveway is original to the home. And I suppose I'll get around to power washing it one of these days and cleaning up a little bit. But For the most part, our product is reinforced concrete. It's well suited for these environments, and that's one of the great benefits is that low maintenance.
Great insight. The next topic I'd kind of like to touch on really combines two different common myths, and that has to do with the environment. So I hear two things, and I think they are kind of related. One, with regard to the environment, is that concrete really is only suitable for certain environments. And then the other common misconception around the environment is that concrete is somehow bad for or damages the environment that it's installed. Can you talk a little bit about concrete and the environments where it's a good fit, and then whether or not concrete in some way would be detrimental to the environment?
Yeah, sure. We'll start with kind of which environments are good for concrete. And what I love about concrete is its versatility. Okay, so our product, if you look at our product photos on our website, you'll see looks the same in a lot of different environments. A lot of times we'll have a similar thickness or a standard beam size, but you have the option to make it stronger without actually changing the piece sizes many times. We had a project in Lake Tahoe that had a snow load of between 200 and 300 pounds a square foot. So this loading condition might be 2 or 3 times what a normal boardwalk is. But rather than having to redesign the whole system, we're able to do things like put more rebar in our concrete or use a higher strength concrete to satisfy those specific site conditions for strength. So it has a strength versatility component, but it also has a durability versatility. We do projects in moderate climates where standard rebar and a standard concrete mix works just great, but we also do some projects that are down in coastal applications, and they might have a lot of salt water or very cold climates. And what we're able to do is design the concrete itself, like the mix design, to be better suited for those environments. We can do that with air entrainment, admixtures, and coming up with a concrete mix that's going to be really suited for that specific environment, whether it be coastal, hot, or cold. And then also the rebar. The other main component to reinforced concrete is the steel rebar. And so for harsher climates, we have the option to use either epoxy coated steel or sometimes more of a chromium infused steel, something that has more corrosion inhibiting ability. So the versatility really makes it where it's not really constrained to a certain type of geography or a certain type of climate.
Well, I appreciate that. Your thoughts on the environment. So let's move on to one particular application that we see more and more often, and that involves installing concrete around a tree, tree roots. So there's a misconception that a concrete structure would harm tree roots. Can you speak a little bit to how a precast concrete boardwalk can be used in a tree protection type of application?
Yeah, we've been getting a lot of requests for boardwalks around tree roots. Saving established mature trees is a great use for a boardwalk where you don't want to pour a sidewalk. We've all seen the sidewalk that's poured right up against a tree, and as it grows over time, those roots push the sidewalk up. So a boardwalk around the tree is great to still have the mobility around the tree, but protect the tree and the mature trees. The design approach I've seen that works best is stop trying to fit the trees around your boardwalk and build your boardwalk around the trees, right? So be able to do a design that looks at that tree, looks at its existing root structure, where they are, and design around that tree so it really fits in with the environment. I think one of the misconceptions is when people think of a concrete boardwalk, they think about like a cast in place concrete footing. So they're thinking in their mind, oh, there's a lot of excavation, a lot of concrete to be poured on site. And yes, cast in place footings around sensitive tree root zones, they can be problematic because you can damage the roots with that excavation. The approach we've established in the design of our boardwalks when we're near trees, it's kind of twofold. One approach is to find out where those tree roots are and to put in a slender, deep foundation element. And the most common choice there is a helical pier. So if we can figure out where those roots are and we can put helical piers at locations where the tree roots are not and go beyond that shallow root structure and establish our bearing capacity needs, that's one approach. Now sometimes the tree root area, there are so many trees or such a large tree root for one big tree, a better approach is to use precast footings. And if the priority is on the tree and protecting that tree, we have a system where we simply set precast pedestals as footings that we make in the plant and bring out and set there. And so you're basically sitting on top of that sensitive root zone. So both of those approaches can be used depending on the project and depending on the trees around it.
You said something that also struck me. You mentioned building the boardwalk around the tree, which kind of gets to another common misconception, which is that precast concrete, because you're most often thinking of concrete as being rectangular panels, that it doesn't handle a radius or a curve very well. Can you talk just a minute about how you can build around a tree or around any feature that requires a curve?
Yeah, so with a precast concrete boardwalk, we don't just have a bunch of rectangular pieces sitting in a factory waiting to be shipped out. We approach each boardwalk custom, so we'll take the layout of the site and we'll draw in a boardwalk that best fits the alignment that's preferred by the designer that the site requires. And the way we do that, John, is we take trapezoidal pieces. So these trapezoidal pieces put together will mimic a curve. And so you're able to create radial geometries with trapezoidal planks and really get a nice, smooth, curved structure that can meet the demands of that site.
All right. And the last misconception we'll hit here today is the idea that really anybody in the industry can produce a precast concrete boardwalk. Can you speak a little bit to the expertise that goes into the manufacturing process?
Yeah, John. So we've learned a lot over our 16 years of focusing just on these precast concrete boardwalks. We have over 700 structures. My dad once said, if you try to do everything, you won't do anything well. But PermaTrak has really evolved our system now. It has integral color options. It has integral texture. The design support we give is really one of the big values. So we have a full engineering staff here ready to tackle these projects early on, get them on the right track, find the right span arrangements, the right widths, and really work with these designers to come up with a product we're happy about.
Okay. Can you tell us more about the environmental impact of precast concrete?
Yeah, I can. This is a topic, John, that comes up a lot lately, and it's a really tough one. I feel like whatever industry you're listening to, they've got the answer, right? They've got the answer on the environmental, and they're the best. I like to look at it two ways, and the first way is more site-specific, okay? So you're thinking about the concerns with your specific site, and what I love about concrete is concrete's a very stable material, okay? Once it's cured, it's somewhat inert, and it doesn't really have that leaching effect. Whereas as timber, treated timber, when it's put in boardwalk applications, is going to have the chemicals, and the chemicals are going to leach out. And that's especially concerning in wetland environments where you're not getting a lot of flow rate. A lot of boardwalks are in these wetland environments. And the most common chemical that's used in treatments today is a copper-based chemical. And even at the early phases of the boardwalk, that copper can start to leach out and it can damage the ecosystem, especially the sensitive wetland ecosystem. So what I learned about concrete for the specific site, it's very stable, it doesn't have a leaching effect. Also, the construction for precast, since it's built off-site and assembled on-site, it generally has a quicker construction, a little bit less impact. Like we said earlier, we generally have less foundation elements for our boardwalks than the timber, so you're just having a little bit less impact, less time out in the sensitive areas. And also, PermaTrak can be built top-down. The strength of the concrete is such that getting equipment on top of the boardwalk is an option if that's necessary for the site. So being able to control that footprint for the site, that's really important for that site-specific look. The second thing I get asked a lot is more global. It's not really for the site-specific, but it's thinking more about the entire planet, the global CO2 emissions. And I'm sure you've heard a lot of people talk about the CO2 emissions. And cement sort of has a bad rap in the industry because the production of cement itself does have a lot of CO2 emission. But if you look at like a life cycle assessment and you compare a concrete boardwalk to a wood boardwalk, what you'll find is you may see CO2 emissions that are approximately 50% higher for that boardwalk. Again, kind of on day one. But similar to looking at the cost, the timber boardwalk would expect 3 replacements in one life cycle of a PermaTrak. And so at the end of the day, when you look at the cradle to grave, which is from start of the PermaTrak structure to the end of its life cycle, you're going to see the effects on the CO2 emissions is naturally going to be about double what it would be for a concrete boardwalk. Just simply stating that you've got to build the timber structure 3 times in the cost of one PermaTrak cycle.
Appreciate that insight on the environmental impacts. That brings us to the end of our time here today. Andrew, I really appreciate your time and your insights. If anybody would like to learn a little bit more, please go to our website at permatrak.com, where you'll find a lot of articles and resources on the topic of not only precast concrete boardwalks, but boardwalks in general. So thank you, and we will check in the next time. Thanks.